do both. So 6x minus 5 divided by x minus 10 minus 3x minus 4 divided by x minus 10. There is only one restriction that I need to write here. What is the only restriction I need to write on the side? That x does not equal 10. So now I have the least common denominator. I am going to copy x minus 10, but now I have to be very careful with the top. The numerator of the first fraction does not change in any way, shape, or form. However, this negative in front of a fraction line must be distributed to all terms in the numerator. This is like writing this. This is what we did at the beginning of the class today. So this minus times 2x is negative 2x. This minus times negative 5 is positive 5. So, because I have to distribute, well, I will write negative 3x, but plus 4. So this is, I combine like terms. Do not try to simplify anything. They're all terms. You can't simplify anything. I can only combine like terms, and I get 3x minus 1 over x minus 10, and this is it. And no one can further simplify that. One remark here. When we add and subtract, we do not factor the tops, the numerators, ever, till the very last step. But there is nothing I can factor here. So I don't factor in this form, even if I can. I don't factor in this form, even if I can. I wait till the very last step when I have only one fraction line. And now I'm asking myself, can I factor it up? No. I'm done. So now let's look at the other one, which looks way more involving. So 2x squared plus 3x over x squared minus 2x minus 63 minus x squared minus 3x plus 21 over x squared minus 2x minus 63 and minus x minus 7 over x squared minus 2x minus 63. Although it's long, although it has three kind of complicated looking rational expressions, it's not difficult. Why? Because all three fractions have the same denominator. If that's the case, I need to factor it. Just the denominator, not the numerators. So please give me the factor form of the denominator. Very good. Then you will give me also two restrictions right away. And you will say x not equal. Very good. And now all I have to do is write the numerators. And if there is a negative in front of a fraction, I have to distribute it to the top. So can anyone dictate the top? Slowly, step by step.
2x squared plus 3x minus x squared plus 3x minus 21 minus x plus 7.
That's it. Don't try to simplify anything other than combine like terms. That's the next step. And I have to start with a degree, with the highest power, right? Because I have to have everything in descending order. So then the top will be x squared. Then I have 3x and minus x. So it's positive 5x. And then minus divided by x minus 9 and x plus 7. At this final step, I'm going to ask myself, can I factor the top? If I can factor the top, I'll go ahead and factor it. Now, just now, you cannot factor these. You should not, and you should not even think of factoring them because we are adding and subtracting. We're not multiplying and dividing. So, can the top be factored? How? If it's minus, then this will be minus.
Oh, right. So x plus 7. X minus 2.
Perfect. Now I'm asking myself, can I further simplify? Or can I simplify this? Because I haven't simplified anything yet. And the answer is?
Yeah.
By?
Factoring out that x plus 7.
Good. So then the final form is x minus 2 over x minus 9, assuming all conditions are fulfilled. And now we get to the real stuff, really. This is, I think I mentioned that I consider two topics difficult in this class. One is radical equations. It's not an easy topic, right? When you square both sides and then simplify and then square again if you need to, and so on and so forth. This is the second one, right? This topic of adding rational expressions with unlike denominators, which is followed by this, solving equations. So, let me remind you one more time how we approach this with unlike denominators. For example, if I have 2 divided by 3 minus 1 divided by 12, have to find the LCD. Yes, I agree. When one is the multiplicative one is a divisor of the other, then it's definitely 12. But here's how I do it. 3 is 3 in prime numbers. 12 is 2 squared times 3 in prime numbers. So the LCD must have all different factors. Must have 2 and must have 3. But 2 has power 2. I have to keep it with the largest power. 3 has power 1. I have to keep it with the largest power. I'm not adding powers. And therefore, I do get 12 as we discussed. So this is 12. 3 was multiplied by 4. 12 was multiplied by 1. I don't need to write the 1 though. 4 times 2 is 8. Minus 1 times 1 is 1. So therefore, the answer is 7 over 12. We're going to use the exact same procedure here. Okay. So I like to start with D. Then you choose. So with D, I have 3 divided by y plus 6 minus 4 divided by y minus 3. First thing that I ask myself is y plus 6 fully factored? Can I factor anything? Yes, it's a linear expression. I cannot factor anything. Y minus 3, linear expression. I cannot even pull out a 2 or a 3 or something. Nothing. So these two are already factored. This is one factor and this is the other. The same concept. How many different factors I see? Well, I see 2 different factors. I see y plus 6 and I see y minus 3. All different factors must be present in the least common denominator. Yes, I would write 2 restrictions, y not equal negative 6 and y not equal 3. And like before, if you remember, after I established the least common denominator, I asked myself 3 times what is this? 4. 12 times what is this? 1. I asked myself the same 2 questions. Y plus 6 times what is this? So what did we multiply y plus 6 by to get this? Well, obviously the other one, right? Y minus 3. So I have to multiply the top of this fraction by y minus 3 because I multiplied the denominator by y minus 3. Now the same thing with y minus 3. What did we multiply y minus 3 by to get this least common denominator, the whole thing? Right. So if I multiply the denominator by y plus 6 to get y plus 6 times y minus 3, I have to multiply the top by the same quantity. Exactly how we did it here. So then, now, this is a product. Be careful. Like here, 4 times 2. I didn't say 4 plus 2 or something like 4 times 2 is 8. 1 times 1 is 1. So y minus 3 gets multiplied by 3. In other words, I have to distribute it to both terms. And the same here, negative 4 gets distributed to those two terms. So when you're ready, dictate the numerator.
3 parentheses y minus 3.
Right. I would like to write, so let me write it with parentheses. Minus 4, y plus 6. The reason why I avoid this step is because several of my students are tempted, I know it's tempting, I give you that, to do this. And that will mess up the whole thing. You can't do it because these are terms. This is a term subtracted from another term, or vice versa, whatever you want to say, it doesn't matter. So that's the reason why I do not write this step. But if you know what you're doing, please use it. I'm okay with it. I just try to avoid it, not to show it to my students because they may be tempted. So instead, I want you to perform the multiplication and give me the multiplied form.
3y minus 9
Exactly.
minus 4y minus 20.
That's it. And now I'm hoping that no one will attempt to simplify anything, right? Because they're all terms. It's clear now that you can't do anything. So all I have to do next is just combine like terms. So when you combine the tops, you will get negative y minus 33 over y plus 6, y minus 3, and you will factor out negative 1. Please factor out negative 1 and tell me what you get at the top. Very good. Because negative 1 times y is negative y, and negative 1 times 33 is negative 33. Excellent. I would like to continue with G. If we get this, and we understand how to add these rational expressions, this will be a breeze. Solving the equations will be a breeze. Okay? Because it's the same thing. We're going to do the same thing. Just there will be an equation instead of an expression. So we have x plus 4. Everything divided by x squared minus x minus 42 plus 3 over 7 minus x. Which part of this sum of two rational expressions you don't like? Yes. Bottom left or bottom right? Bottom left is fine. Bottom left is fine because I can factor it, it's not a problem, but I don't like the bottom right because it's not in the correct order. So now it is in the correct order, but I still don't like it. Right. So I have to factor out negative 1. What do I write? Very good. So now let's go back slowly to the first one. I have x plus 4 at the top, and I know I have to factor. Denominators have to be factored all the time. In a product, addition, multiplication, division, it doesn't matter. Denominators have to be factored. So how do I factor the denominator? Very good. Now, careful. So I have positive 3 at the top, right? And the denominator is this now, right? So I write positive, I write 3, and over negative x minus 7. Do we agree with this? Okay, I'm not there yet. Since 3 does not have any sign in front, obviously it's positive. But now tell me, please, when I divide a positive by a negative, what do I do with this? What is the sign of this expression when I divide a positive by a negative? And since it has positive in front, that will not change anything, right? It will still stay negative. So now, after all this work, I finally have this. And now I'm ready to find the LCD and state 2 restrictions. And what are they? Very good. And what is the least common denominator? Indeed, 7 and negative 6. And the least common denominator is?
X minus 7 squared, x plus 6.
Very good. Remember? Let's go. Excellent. Here I had a 3, and here I had a 3. I have to choose the highest exponent. I'm not going to add power of 3, 1, and the other power of 3, 1, 1 plus 1, and put 2 here. But you're right. Don't change anything. I'm going to erase it, okay? If I have this, then I have to choose the highest power for x minus 7, which will be 2. But since they're both with power 1, I have to keep power 1. And then x plus 6. Don't write that. I'm going to erase it right now. So is the largest or the greatest multiple the smallest multiple that has these x plus minus 7, x plus 6, and x minus 7 as divisors, right? So let me give you an example. If I have 1 over 4 plus 1 over 16, I'm not going to say 16 times 4, right? Because 16 is good enough. You can put any power you want above 1. They will all work, but they will not be the least common denominator. They will be much bigger. Okay, so now this is the same denominator. I make myself a note, multiply by 1. But this is not the same denominator. The denominator here was multiplied by x plus 6. Then therefore, the numerator has to get the same quantity as the denominator did, which is, that's it. So now please give me the numerator.
X plus 1 minus x plus 7.
I have to distribute 3 and minus 3 actually. Very good, excellent. So now negative 3x plus x is negative 2x, and 4 plus 18 is 22 over the whole denominator. And yes, I will factor out what? Although I will not be able to further simplify, but I will still factor what in the numerator, as we discussed in chapter 6. 2. Perfect. Negative outside in front of the fraction line, 2 stays up in the numerator, and then in parentheses we have, careful,
X plus 11
but minus,
minus.
right? Because I have negative 2x, right? And negative 2 times negative 11, which will be positive 22. So this, with the restrictions, is the simplified form. Now, please choose whatever you want.
We do A.
Which one?
A.
Very good. So let's do A. So 1 over 2x minus 5 over 4x plus 7 over 6x. Here's what I recommend. Of course, the only restriction will be x not equal. Perfect. Very good. And I recommend the following calculations on the side. 2x is already in factored form. There is nothing I can do to present it simpler than that. 4x, however, will be 2 squared times x in prime factors. And how will I write 6x? 2 times 3 times x. 6 is 2 times 3 times x. Now, how many different factors? Disregard the powers. How many different factors you see here? Yes, I see 2, I see 3, and I see x. All have to be in the LCD. But now we have to discuss exponents. What is the larger power for 2 that you see in any of them? There is power 1 here, there is power 2 here, and there's power 1 here. What is the yes, I have to copy the largest power. Not add powers, but copy the largest power. What is the largest power for 3? 1. What is the largest power for x? 1. This will be the LCD, which is? That's it. I like to call those quantities that I write at the top, I call them adjustments. I need to adjust the numerator. What do I adjust? You don't have to use my terminology. You use what you know and what makes you comfortable. So if we talk about adjustments, what will you adjust the numerator by? That's it. What will you adjust the numerator of the second fraction by? Is that clear how we get these? Nicole? Is that clear how we get these?
Yeah.
12x divided by 2x is 6.
Yeah.
12x divided by 4x is 3. And 12x divided by 6x is?
2.
Perfect. So now the numerator becomes 6 minus, yes, and plus. That's it. So negative 15 plus 14 is negative 1. 6 minus 1 is. So assuming that x is not 0, the simplified form of this addition, subtraction of rational expressions, they are rational expressions because they have x in the denominator. Okay, let's choose one more, and then I'd like to look at some equations. Which one?
C.
C. Very good. So let's work on C. So C is 5. Wise to write 5 over 1 minus x minus 2 over x plus 1. Very good. So we did C. Good. What is the least common denominator? Actually, there is only one denominator, to be honest. That's it. What is the only restriction that you will give? Perfect. And what is the adjustment that you will use on 5? 5 needs to be adjusted by? That's it. So please dictate the numerator.
5x plus 9 minus x plus 2.
Wonderful. All we have to do is combine like terms, and 5x minus x is 4x plus 7 over x plus 1. I would like to simplify x with x. No. Very good. Very good. Okay. We want to choose another, or we want to go to equations. We'll come back to all of them. I promise. But if you want to choose, f is twisted. Look at this. Twisted situation. H is twisted. Look at this. I don't like those. I don't like this. I don't like this. So if you want to choose another, right, right. I agree. I agree there. They require a lot. See, with this, I test like 5 different things. I test whether you can find the least common denominator. I test whether you can factor. I test whether you can find those adjustments for the top. I test whether you can state restrictions. I test whether you can add and subtract and distribute -1 and combine like terms and factor again. I mean, I can continue forever. One problem. So, which one?
Actually, can we do F?
Yes, let's do F. Good. Okay, so x divided by 1 minus x squared minus 1 plus 1 over 1 plus x. You want to think about it for a minute, or you want us to start?
Can we just start?
Yes. Okay. I don't like the denominator of the first one. Let's take it aside. 1 minus x squared. What would you do to it? You will rearrange it as negative x squared plus 1 as we discussed in chapter 6. That's mandatory. Then you will factor out -1. That's also mandatory.
So it'd be X squared minus.
Perfect. And then also, like in chapter 6, I have to factor it. See, just one little denominator, I had to write 3 lines here to get it to work for us. So how do I factor? It's the first agreement we made on the first day of classes. It's one of the formulas in there. Is?
X plus 9, X plus 9.
Good. So let's write the whole thing carefully, slowly. I copied x, but now I copy in the denominator negative x plus 1 times x minus 1. Are you with me so far? Then I copy, instead of -1, I will copy -1 over 1, so I don't forget what that is. And then plus 1 over x plus 1, I also put that denominator in order, in the correct order. Now, what did we do with that sign in the denominator? We looked at the numerator. We realized that this was positive. Positive divided by negative is negative, so that's why there is a negative now in front of the fraction line. X over x plus 1, x minus 1, minus 1 over 1, plus 1 over x plus 1. And you will give me 2 restrictions. So after 3 minutes, I only rearranged the problem so I can start finding the LCD. I didn't do anything yet. So x cannot be Very good. That's the restriction. Excellent. 1 or negative 1. And now I have to find the LCD. All different factors taken at the or written with the highest power without adding powers. So then the denominator will be that's it. Adjustments on the first one, the top. Does it need anything? No. Well, I'm going to write 1. What about the adjustment on the second one? The answer is the whole thing. But I want to multiply it. I don't want to write it here and then have to multiply it. So when I multiply these two, what do I get?
X squared.
I'm going to write it already multiplied. It saves time. What about the adjustment on the third one? Does the third one need anything? Exactly. And now, slowly and carefully, dictate the numerator. Don't forget the minus in front of the fraction. Wonderful. Now I'm distributing this to these two terms.
So minus x squared plus 1
Very good. Now I'm distributing positive 1 to these two.
plus x minus 1.
Exactly. Awesome. In descending order, and I notice one thing. Look. I cross them out because negative x plus x is 0. I'm not simplifying with anything in the denominator. So then what is left at the top? And also, I'm sorry. And yes, I just realized. So then I have negative, just x squared at the top over x plus 1 times x minus 1. We want the denominator to be factored. So leave it alone as is. So look, it took us, what, 6 or 7 minutes, just one problem. Once again, what did I do? I realized that this was twisted. I had to take it aside. Factor a negative 1. Factor again. Put it here. Realize that this is positive of a negative, so I can put a negative in front. Then I found the least common denominator, stated restrictions. And then the adjustments. It will be a terrible mistake to write here negative x minus 1 plus 1. That would be a terrible mistake. Because you have to change all these fractions into the same fractions with the same denominator. Otherwise, you can't add them. Okay, so then we are going to leave these for next time, okay? Okay, I would like to look at equations. I'm not skipping this. This is very important. But I need to continue with the equations because this is exactly what we just did and we have it fresh in our minds. Okay. Rational equations. We're going to look at two different types. Type 1 and type 2. Nobody calls them type 1 and type 2. I just want you to remember there are two types. One is a proportion. I'll put in parentheses, easy. The other one is not a proportion. Not easy. Let's start with the easy one. Let's discuss, first of all, what a proportion is. So two types of rational equations. One which is a proportion and the other one which is not. Okay, so let's talk about proportions. This is a proportion. One fraction, nothing else attached to it, nothing. The equal symbol, another fraction on the other side, nothing attached to it. This is what we call a proportion. Why is this so Important, because only in a proportion we are allowed to cross multiply. I'm not saying multiply across, I'm saying cross multiply, which means if this is true, then A times D must equal B times C. Guaranteed. And this makes it so easy. So let's start with those. Can you look at these 5 examples, 6, I'm sorry, and say, and choose a proportion? Do not choose a non-proportion yet. Or let's, yes, E and which is the other one that is a proportion? Exactly. So let's start with E and F. In E, I have 6 over 5 minus 2x equals 2, or 2 over 1. This is clearly a proportion. I will go ahead and cross multiply, but not before I do one thing, which is exactly, thank you. I have to write on the side that x cannot be, should not be, and if I get this as a solution, I'll say, sorry, the equation has no solutions. That's why restrictions are so important. So I will write 5 minus 2x cannot be 0. I will move 5. Negative 2x cannot be negative 5. Therefore, x cannot be. Very good. So whatever else I get, it will be acceptable. But if I get 5 over 2, I'll say, sorry, the equation has no solutions. So now I can go ahead and cross multiply. Some students ask me, okay, after I write this, 6 equals 2 quantity 5 minus 2x, they ask me, okay, where does the denominator go? Right? So here's where it went, right? So if this is a proportion, I'm allowed to cross multiply. It didn't go anywhere, it's right there, but it's no longer a ratio, no longer an exponential, a rational expression. Okay, so now this is linear, I distribute. I can simplify. If you want, I would love to simplify both sides by 2. And if I do that, then I have 3 equals 5 minus 2x. Or just distribute. You don't have to simplify. I recommend it though. And then I move 5 to the other side. I get negative 2 equals negative 2x, so x equals 1. My first thought is 1 on the list of restrictions? It's not. So this is it. Any questions? Let's look at the other proportion. X over 2 equals 1 over 3x plus 5. Is this a proportion? Yes, so that's easy. But I have to state a restriction though. 3x plus 5 cannot be 0, or 3x cannot be negative 5. Therefore, x cannot be negative 5/3. Now, the denominator doesn't go away. It is incorporated in the product now. So one side is 2, and the other one I recommend distribute if you want to do it in one step. 3x squared plus 5x. So this rational equation, which was a proportion, changed into what type of equation? This word should be on our minds because we've dealt with quadratic. Now I have to dig deep. Okay, how do I solve a quadratic equation? I have 4 methods, but I definitely, in this case, I have to set it equal to exactly. So I subtract 2 from both sides. 3x squared plus 5x minus 2 equals 0. No one told me specifically to factor. If you want to use the quadratic formula, go ahead and use the quadratic formula. If factoring takes 30 seconds, use factoring. If it doesn't take 30 seconds, we already have the other way, which is the quadratic formula. So you don't have to struggle through factoring anymore. Which one would you like? Would you like factor or quadratic formula? Well, see, the product is -6 and the sum is 5. So they're not big numbers. It's not going to take an hour to factor, right? So let's factor. So the product is negative. So the product is negative. And I need the product of -6. Since the sum is +5, I need the other one. If it's not 2 times 3, there is only one more chance to get a 6. 6 and 1. And the sum is 5. Product is -6, sum is 5. Okay? Is that okay? Good. So now we change this. So we have 3x squared minus x plus 6x minus 2 equals 0. What do I factor out from the first two? And what do I have left? What do I have to have left from the other two? It's a must. And then I have a positive. So 2 times 3x and 2 times, very good. So now 3x minus 1 times x plus 2. And I finally have x equals 1/3 and x equals -2. My first thought is here. Are these solutions, prospect solutions I will call them, on the restrictions list? No. So they must be assuming that I didn't make a mistake. Any questions? I would like to stop after one problem. I know I have like 8 minutes. One problem that is not a proportion, and then we'll stop. Now let's see what is left for after Thanksgiving. So these 4 problems, these are not difficult, but they can get difficult. So we're going to work on these 4 problems and whatever is left from all of them and these equations. And then we'll go to chapter 12. Okay, so I'm going to copy the first one. So I'm going to copy the first one. So we have left B, C, and D. Okay. So x over x plus 4 minus 4 over x minus 4 equals x squared plus 16 over x squared minus 16. Again, this is a method that I like to use. If you go to the math lab and they show you a different method that you understand, forget about mine. Whatever works for you, I'm fine. Okay. I prefer having everything set equal to 0, which means since this fraction has positive in front, I would like to move it to the other side and it will change its sign. I copy the first, I copy the second, but minus the third. And of course, I have to factor the denominator. How do I factor the denominator of this fraction? Always look at the other two because it's not going to be something weird with 5 different factors in the denominator. It will take you an hour, right? So always, it's not cheating, but we don't expect in this class to have super sophisticated rational expressions. They are hard enough. I will on the side have to write 2 restrictions before I start. Yes. Then look what I did. I drew the long fraction line, the equal symbol and 0, because if I forget the equal symbol and 0, I change the equation to an expression and I will never solve. Now I'm going to ask you, what is the LCD? Nothing is different, right, from before. Just this 0 is now following us.
X plus 4 X minus 6. No, you're good. Please, whenever.
There is an adjustment needed for the first one.
X minus 4.
Exactly what it does not have in the denominator. Correct. There is an adjustment for the top of the second one.
X plus 4.
Correct. Now exactly what we did before, dictate the numerator. But already multiplied, so we don't get into any temptations.
X squared minus 4x.
Excellent.
Minus 4x minus 16 minus x squared plus 16.
Careful.
Minus 16.
Exactly, because you distribute a negative 1 to x squared, you have to distribute it all the way only to the top. Excellent. Okay. Do you remember how we call this? Assuming that I put 0 over 1. Yes, 0 or 0 over 1 is the same. But what does this, what did we change this into? What is this?
So what
Yes.
we called the last one?
Yes.
The
Proportion. That was my goal, to change this blah thing into a proportion so I can cross multiply. But of course I'm not there yet. So let's look at the top and combine like terms. The x squared with negative x squared will go away. I have a negative 4x with a negative 4x, which is negative 8x, and a negative 32 over x plus 4 times x minus 4 equals 0 over 1. This is even easier than a proportion because there is a 0 in there. But it is a proportion still. So can anyone dictate what happens next? This is what happens next. This product is negative 8x minus 32. And this product, very good. What did you say, Nicole?
That, for some reason, I thought it was going to be set up as a fraction at the end, but if it was over 0, it would be undefined. But
Right, no, I cannot have 0 in the denominator. If I had here 5, I would have written 5 over 1, but I have 0, so I write 0 over 1. So I move 32, so I get negative 8x equals 32. So then x equals? Here's my first thought, immediately. And what do I conclude? Not acceptable. The equation has no solutions. But if I don't state the restrictions, and if I don't go back and check, which will take me some time, right? Maybe. And consider this a solution, I lose points. See how elegant this is if you keep that in mind? And then there is nothing you need to do. Just write no solutions. So again, we covered a lot today. So you can do, in my Labs Plus, you can do section 7.1. You can do section 7.2. Please bring all your questions to class. You can do 7.3. You can do 7.4. And you can do 7.5. So we finished 5 sections. I have to present 7.6 and 7.7. And then chapter